This is because, you know, I have noticed I'm not following the sequence of your book. Okay, your book has, you know, very lightly has, you know, talked about for formula writing, and it has not talked about it in detail, which I don't like, because you know, in the chapter of periodic table, then they are talking about reactions of metals, and then they're talking about reactions of non-metals, and they're giving you equations, and then you are expected to write the formulae correctly, and you're also expected to balance the equations when they have not taught you. Okay, so when my daughter was in grade 6, I faced this problem that, you know, they have jumped onto the reactions without teaching the students how to write formulae and how to balance equations. And then, you know, the students are confused. And I have seen that even students of grade 8 and 9 are not able to write the formulae correctly. Sometimes they are not even able to differentiate between ions and atoms. So in order to address that problem, I have decided that I will talk about formulae writing and balancing equation, and I will give lots and lots of classes and practice to this until you are good at it, inshallah ta'ala, with the help of Allah. And so let's start, okay? So just a recap, I tried to make this periodic table myself, okay? I made this periodic table myself. It's pretty easy. These are transition metals. I just made 3 groups here. Okay, so let's recap real quick. Muhammad Hashir, this is the second time your video is on. This is the second time, okay? Or after 2 warnings, I will remove you if your video is on. I hope this is happening by mistake, but if it is, please make sure this does not happen again. Ahmad? Okay. Yeah, please choose that option in which your video is off when you join the meeting. Okay, okay, so just a quick recap. What are ionic compounds? What are covalent compounds? Anybody? What's an ionic compound? What's a covalent compound? Real in short detail, short answer, short and to the point. Short and to the point. Okay, Saeed Khan, formula or formulae? Formulae is a plural of formula. Okay, formula is singular. Formulae, you know, where you have AE at the end, is plural. Okay, and always write your answer in complete sentences. Don't expect me to understand your shortcuts. Ionic compounds give electrons, they don't share them. Yes, Aisha, ionic compound is when a metal and a non-metal react to lose and gain electrons. Who is Kylie Jenner? You will be removed. I'm removing you because you are using fake name. Yeah, and once I remove, you will not be able to join. Okay, I have removed Kylie Jenner, whoever that was. And I do not appreciate names from entertainment industries. And I do not appreciate names which are fake, especially these actors, actresses names, movie star names. No way, no way. I have zero tolerance for that. Okay, I'm sorry about that. Okay, so yes, when covalent compounds are when 2 non-metals share electrons. Aisha, wonderful, wonderful, Aisha. Ionic compound is when a metal and a non-metal. Okay, very good. Yes. So, okay, good job. So that means, okay, we have grade 8 students here as well as 6th grade students. I invited grade 8 students because I feel that grade 8 students also very frequently face this problem of not being able to write the correct formulae. Okay, so yes, ionic is, so let's yeah, so most of you already know it, but you know, just a recap, ionic compound is between a metal and a non-metal, where a metal completely gives away an electron and becomes a positively charged ion. What is an ion? Ion are charged particles, right? Ion are charged particles. Now, why am I using the word particle? It can be single atom, it can be a group of atom, but the thing is that they are charged, okay? Charged particles are called ions. So a metal that completely gives away electron becomes cation, okay, becomes a positively charged ion, and non-metal is the one that accepts an electron and becomes a negatively charged particle. So the transfer of electron is complete, okay? Now this is a positively charged ion, this is a negatively charged ion, and what keeps them together is the electrostatic attraction between the oppositely charged particles. Now, on the other hand, covalent compounds they can be compounds or they can be elements. By the way, ionic cannot be elements because they have to be different to be able to give an electron and to be able to gain electron, right? So, when we're talking about covalent compounds or elements meaning made up of the same type of atom. For example, this. Okay, for example, this, a same type of atom, which is hydrogen atom, and they are sharing electrons. This happens when both the atoms want to gain electrons, to gain a stability, meaning that no one of them is ready to give an electron. Both of them want to get an electron. Both of them want to gain an electron. So that's why when they make a covalent bond. Now, just a quick question. Which bond do you think is stronger? Ionic or covalent, and why? Any guesses? Zor se bolo.
Covalent.
Covalent. Okay, why?
Because they're sharing, so they're closer.
They're sharing and so they're closer. Okay, and what about the electrostatic attraction between the oppositely charged particles? I think that is also a pretty strong bond, right? What makes you say that covalent is stronger? Yes. Ionic, because positive and negative charges attract. Saad Ahmad, okay. Ionic, because both atoms are oppositely charged. Yeah. Covalent, Ishal is saying covalent, Mariam Wasim is saying covalent. Okay. Yeah, you know, when I was a student, this confused me. So I'm gonna, I don't want you to be confused. So let me share the answer. This is very important. Okay, it helps you understand many things ahead. Covalent is stronger. Covalent is stronger. You know why? I'll tell you. Sadaf Azam, your video is on. Okay. Now, in ionic compounds, the metal has lost an electron, and so it is now stable. The reason why the cation and the reason why it lost an electron was to gain a stability, and now it has completely gained an electron. So it has accepted, and so it is stable. So the only thing which is keeping them together is the attraction, right? If somehow they separate, do you think they would be unstable? No, they have acquired their stable configurations. This has complete octet, this has complete octet, so they're fine. It was only the attraction that was keeping them together. Here in this case, if they separate, can they live without each other? If they separate, they will end up, this hydrogen will end up with only one electron, and this hydrogen atom will end up with only one electron. So they are unstable, they are unhappy. They are unhappy. They cannot live without each other. They have to be together to have that stability. Here, it was only the attraction that was keeping them, but they are stable without each other. Okay, now without warning, I'm gonna remove. I don't know why so many people are having their videos on. You know, it's disturbing me now. Okay, so that is why covalent is more important, because these atoms are unstable without each other and they cannot live without each other. So they have to be together. Okay, and also in my last class, I discussed that electrons sharing means that this electron is revolving around both the nuclei. Maliha Nasim? So this electron is revolving around both the nuclei. Nuclei, you know what is, why this nuclei? I remember somebody was asking me, why are you using EI? EI is the plural of nucleus, singular is nucleus. Singular nucleus is singular, nuclei is plural. Okay, Sundus, you go ahead. This is your job. Anybody whose video is on twice, you remove that person, okay? Because they're disturbing me. Okay, so once you have understood ionic and covalent, let's try to understand keeping this periodic table in our mind. So remember, this was our staircase. I talked about this staircase. Elements in the periodic table which are on the left side of the staircase are all metals. Do you understand that? These are all metals, and on the right hand side are all non-metals, okay? And around the staircase are metalloids. Metalloids which have characteristics of both non-metals and metals. So you can say that they're combined. The metal and non-metallic properties are combined, okay, which include these the elements which are close to the staircase. But on the left hand side we have all metals. On the right hand side of the staircase we have non-metals. On the left hand side we have metals, and on the right hand side we have non-metals. Then we have different types of metals, like these are transition metals. And I will talk about transition metals in detail. And then these are group 1 and group 2. Alkali, their name is alkali metals, and these are called alkaline earth metals. And why are they called this? That we will deal with when we will do the periodic table in detail. Okay, so now I want you to tell me which one of these compounds are ionic and which one of them are covalent. So I have made this list of compounds. I want you to tell me, what is element 1? Is it a metal or a non-metal? Element 2, is it a metal or non-metal? And so we will decide what type of atom is there in this compound. Because remember, ionic, remember this, ionic is between metal and non-metal, and covalent is between non-metal and non-metal. So if both the elements are non-metals, we will have covalent. Okay, if we have metal and non-metal, then we have ionic. Okay, is it for the second time? Okay, remove. Okay, so now tell me, what about this compound? What about this compound? What do you think? Element 1 is nitrogen. Is it a metal or a non-metal? Nitrogen. Let's see. Where is nitrogen in the periodic table? Nitrogen is here. So it's on the right side of the staircase, right? It's on the right side of the staircase. So is it these are all non-metal. So that means this nitrogen is a non-metal. So I will go ahead and I will write non-metal. Nitrogen is a non-metal. What about oxygen? Where is oxygen? Oxygen, non-metal, on the right side of the staircase. Okay, so both of them are non-metals. So when element 1 and element 2, both of them are non-metals, what will be my bond type? Non-metal, non-metal. Bond is covalent, meaning both of them want to gain electrons, and so they will share, okay, rather than losing completely and gaining completely. So this is covalent. Okay, okay. What about this? See, before you learn how to write formulae, you have to understand, you have to be able to decide if a compound is ionic or covalent. So that's why doing this is important. Now tell me, what about this? Who will do this? Raise your hands. Amar. Okay, how do I unmute? Okay, okay. Ammar or Amar, I don't know how to pronounce your name. I'm unmuting you. Yes. Okay.
Yes, element 1, sodium is in metal.
Very good. Why? Because it is
on the left side of the periodic table.
Yes, it is on the left side of the staircase. Okay, look at the staircase. Okay, can you see the staircase?
Yes.
Yes. On the left side of the staircase are all metals. On the right side of the staircase are all non-metals. Okay, remember this. So sodium is on the left side, so it is a metal. Okay, so this is a metal. Okay, then chlorine. Ammar?
It's in metal.
Huh?
It's in metal.
It's a metal?
No, teacher, so it's a non-metal.
Look at this. Chlorine is here on the right side. On the
Right side, so teacher, it's a non-metal.
It's a non-metal. Okay, so what kind of bond between metal and non-metal?
Ionic.
Ionic. What do we mean by ionic? What do you mean by ionic, Ammar?
The ionic, the ionic compounds that to gain, they lose electrons. They lose and gain electrons to gain stability.
Very good job. Very good. Good job. I'm happy with you. Okay, mute yourself. Okay, sulfur
Okay.
dioxide. Sabiha Azhar. Sabiha Azhar, please go ahead and mute yourself. Yes, Sabiha?
Yes.
Yes, now tell me. So, what is the first element?
Sulfur.
Okay, is it metal or non-metal? Look at it.
No.
Non-metal?
Yes.
Sure? Yes. Okay, so it's a non-metal. Now, what is the other element?
Oxygen.
Yes, what is oxygen?
Non-metal.
Non-metal. Okay, so non-metal. So now we have non-metal and non-metal. So what is the bonding between non-metal and non-metal?
Covalent.
Covalent. What does covalent mean?
Covalent means that the two atoms they share
Very good.
to become
Yes.
stable.
Yes, very good. Very good. Okay. Now you mute yourself. Okay, Fatima Mohsin. Yes, Fatima. Okay. Fatima Mohsin, please hurry up. Fatima? Okay. Javeria. Javeria?
First one is phosphorus, so it's a non-metal.
Very good.
And iodine is also a non-metal.
Yes, on the right side of the staircase. Okay. Do you have this staircase made in the periodic table in your book? You have it,
Yes.
right?
Yes, we have it.
Yes, you have it. So it's easy for you to make out that whether an element is on the left, on the right side of the staircase or on the left side. Okay. So non-metal and non-metal. So what do you think?
Non-metal and non-metal will be covalent.
Covalent. Very good. Okay. So there's a whole list. Okay, you can go ahead and do all of them. I can share in the group, or you can even Google. Okay, there are lots and lots of worksheet. Go ahead and do all of them. Okay, and so it will be, I mean, till you get good at it. Okay. So I have this big list I can even share. Okay, go ahead and do all of them. And by deciding whether the two elements are ionic, I mean the two metals are metals or non-metals, you can decide what the bond type will be. Okay, so I'm not doing all of them. I think you are getting an idea. Sidra, did you get an idea? Okay, so let's move on. Okay, now how to write formulae of simple binary ionic compounds. What do I mean by binary? The word binary means made up of only two types of elements, meaning only two types of elements make this compound. And remember what a compound was. Compound is a molecule or a substance which is made up of more than one type of element, which is made up of more than one type of element. So that we have already done. So I'm assuming this is the second time. Okay, remove. Okay, so simple compounds, type 1 ionic compounds. What do I mean by that? Binary means only two types of elements. Okay, and type 1 meaning that in these compounds you will come across metals which are not transition. Metals I mean, you will have metals on the left side of the staircase, but not transition. Okay? Okay? Transition metals will make type 2. Okay? We will discuss them separately. And if type 1 and type 2 is confusing you, then just forget it. Just understand that we are talking about simple ionic compounds with simple metals. I mean, metals other than transition. We are not talking about transition because transition metals are a little complicated. Okay. So when you see a name of a compound, for example, this, how do you write the formula? Okay. So you look at the name of the first element. Okay, this is the first element. You look at its symbol. In the periodic table, potassium is here. So symbol is K. So I will write down K. Okay. And what is the charge on potassium? Remember, group 1 have charge of +1. And we discussed why. Remember, they have 1 electron in their outermost shell, which they will be happy to give away because they want to have the complete octet complete second shell, right? Or the complete outermost shell. And so they, all of these elements, I have not written all the symbols. You can go ahead and write them. I mean, yeah, but you know, these are the most common ones. So I just wrote down these. Okay, so they have +1 charge, right? So potassium will have +1 charge on it because potassium is from group 1. Because remember, in compounds, it's actually their ions which combine. Okay, in compounds, you don't have neutral atoms combining together. You have ions combining together. Okay, so potassium ion will always have a charge of +1 because it has only 1 electron in its outermost shell. Then we have oxide. If you remember, I don't know if I mentioned this, that ide suffix, the suffix ide represents that this whole compound has only 2 elements. This whole compound has only 2 elements. So the other is oxygen. Okay, the other is oxygen. Now, oxygen is in this group, which has a charge of -2. Oxygen lives in 6th group. And the elements that live in 6th group have charge -2. Okay, so this is -2. Now remember, all the compounds should be electrically neutral. They should be electrically neutral. Do you think this is electrically neutral? We have +1 and -2. Do you think this is balanced? No, we have a net -1. See, +1 -2, you get -1. Okay, so what should I do that this gets electrically balanced? Yeah, so we cannot subtract anything, we cannot take out anything, but we can add. In chemistry, for balancing and for writing formulae, remember, we cannot take out anything, but we can add. Okay, so we will add 1 more potassium. Can we add 1 more potassium? So now we will have total of +2 and -2. So now we are balanced, right? So now how many of potassium did I need? 2 potassiums and 1 oxygen. Okay, and remember, whenever we are writing the number of atoms within a molecule, whenever we are writing the number of atoms within a particle which behaves as 1 in chemical reactions and which does not separate in boiling, in evaporation, that number of atoms within that 1 particle is written as a small number on the right lower side of the symbol. Okay, but when we are representing the total number of the whole particle, okay, for example, this oxygen would look something like this. You know, 2 potassium ions getting attracted to an oxygen. So they will stick together like this because this is an ionic compound. Okay, this is an ionic compound, right? Because potassium is on the left side of the staircase and oxygen is on the right side of the staircase. So metal with non-metal, always ionic. So completely given away an electron. This has completely gained an electron. So these are positively charged. This is negatively charged. And it is the attraction between the positive and negative that is keeping them together. Okay. So total charge now would be 0, and so this will be neutral. Okay, so the formula is K2O. Okay, right. Now let's do silver sulfide. Let's do silver sulfide. What's the symbol for silver? Symbol for silver is Ag. So I will write Ag. Okay, sulfide. Can I have that copy? Can I write it here? Okay, let me write it here. So I have silver sulfide. Okay, silver symbol is Ag. Ide is telling me that that means there are only two elements here. There are only two elements here, silver and sulfur. Okay, silver, charge on silver is always +1. Now silver is a little complicated because it's in transition metal. It's a transition metal. So just by looking at the periodic table, you might not be able to tell its charge. So we will have to learn this. Okay, I don't like students learning. I try to give them shortcuts on how to understand. I mean, I always encourage students to understand and not memorize, but this is one of the few things that you might have to learn, is that what charges can these transition metals have. That's why I'm saying transition metals are a little complicated. So silver has +1 charge. Okay, silver has +1 charge, so we know that. Okay, and that's a given fact. Okay, so +1 charge. Okay, sulfur. What about sulfur? Sulfur lives in the 6th group. Sophia Sohail, remove. Okay, sulfur is in 6th group. It has -2 charge, and so -2. Now, do you think they are balanced? Do you think they are balanced, +1 and -2? No. So in order to balance, what should I do? I should add another silver, right? Silver ion. And so now I have +2 and a -2. Okay. So now, how many silver ions do I have in one particle? Ag2S, and only one of sulfur, because the whole sulfur had -2 on it, right? So silver sulfide formula would be this. Okay. Now let me do one more. Let me do one more example. Let's do calcium iodide. Let's do calcium iodide. Does anybody want to do? Does anybody want to do? Zores, let's see. Okay, I'm unmuting you. Zores, I saw your hand raised. Okay, Iman Javed. I'm trying to unmute you. Okay, you guys are not getting unmuted.
Yes, teacher.
Yes, Iman. Okay, thank you. Can you do this? Can you tell me how to write its formula?
Calcium is in group 2.
Right. So what's the symbol? You can use my periodic table if you don't have one. Calcium is here.
So its symbol is Ca.
Okay, Ca. And this is I. That means only 2 elements are here. And so what element is this?
Iodine.
Iodine. Iodine is here in the 7th group. Okay. Okay. So what's the charge on calcium?
+2.
+2. What's the charge on iodine?
-1.
-1. Are they balanced? Is this balanced?
No.
Okay, how can we balance this?
We will add one more iodine.
Iodine nahi beta, iodide. Okay, okay, this reminds me, I will tell you another thing. When do you say iodine? When to say iodide? Okay, we will talk about that. So this is +2, this is -2. They get cancelled. And so we get, there's only, okay, now tell me the final.
Ca
Right,
I
right,
2.
right. Now when we don't write any number, that means there is 1. Right? When we don't write any number, that means there is 1. We don't write 1. Okay? Okay, another thing. When you put the plus or minus after the number, that shows charge. That shows charge. Okay? And then, okay, I won't talk about this because this might confuse you. So leave this. Okay. So this is the final formula, CaI2. What is the difference between this, and this? What are their names? Who will tell me? What are the differences between this, and this? Ahmad, Atif. Yes, Ahmad? Oh, Muhammad Rayyan. Sorry, I unmuted Muhammad Rayyan. Yes, Muhammad Rayyan, 6B.
Yes.
Yes, can you please tell me the difference between these three?
The second one is called iodide because it is it is 2.
It is called iodide.
I think so.
No, beta. No. Okay. Urva. Urva. Urva.
Yes,
Yes.
ma'am.
Yes, please tell me. Do you know the difference amongst these three?
Iodine is atom.
This, the
First
second
one.
one with the 2.
First.
The first one,
Yes.
is this an atom? Yes, please say it. Yes, this is an atom. Okay. Be confident in your answer. It's okay to make mistakes. It's okay. I know this. I know that you're in grade 6. You don't know this. Okay. You guys have not started your classes. I know you don't know. Okay. So it's okay to make mistakes. We are here to learn. Okay. So yes, this is an atom. I understand this. Okay. This is correct. So the name would be iodine atom. Simple iodine. Okay. Ine. I-N-E. Okay. What about this? What is
Covalent.
this? This is what?
Covalent.
Yeah, covalent what? Covalent is the type of bond you're saying, but what is it? What is the particle called? What is this particle?
Compound.
No, beta, compound has to have 2 different elements. This is the same element. See, it's like this. 2 iodines sharing.
Molecule.
Yes, molecule. So it's like this. This is a molecule, 2 atoms together sharing their electrons. So this is a molecule. This will behave as one particle. So this is a molecule made up of 2 iodine atoms bonded together covalently. Why? Because both of them are non-metals. Both of them are trying to gain electrons. Is he doing for the second time? Okay. Abdullah Khan, your video was on, and the second time you open it, then you will be gone. Okay, what is this, Urwa?
Iodide.
Very good. So we will again use iodine, ene suffix, okay, for molecule. And this is iodide. What is it? Yeah, the name will have ide, but what is it?
Iron.
Iron. This is an iron. Okay. Please understand this difference, all of you. Okay, Urwa, Jazakallahu khairan. You can mute yourself. Now, I have seen students, even of grade 8, even of grade 9, making this mistake. Please try to understand the difference. This is one single atom, okay? One single atom that has not reacted with anything, has not given or taken electron, okay? Simple neutral single atom, okay? We call it with its complete name, iodine. Okay, this is a molecule, two iodine atoms together, same atoms sharing electrons making a molecule. This also has the same name, iodine. To differentiate, we can just add iodine molecule, but basically it's called iodine. Iodine gas, iodine vapors, liquid iodine, like that. But when you have charged particle, when you have an ion, then the suffix changes and the suffix becomes "ide." The suffix becomes "ide" for non-metals. And this is for non-metals only. Non-metals meaning on the right side of the staircase. Elements on the right side of the staircase. You understand that? So this is a negatively charged ion, and therefore I'm using "ide." Okay? Okay, do you understand? So when he said iodine here, I did not like it. Why? Because this was an ion. You shouldn't be calling "ine." You should be calling "ide." Iodide. Okay? Keep practicing, keep practicing. You will understand the difference. Okay? Keep practicing. Okay. Let's do one more. Let's do gallium oxide. And don't be scared of the names, like we never heard of this name before. Okay, another thing, when you name, okay, we will do naming of compounds as well, but for now, understand that for naming of compounds, it is not necessary for you to write down the name with the capital letters. No need to capitalize. You can use small letters. At many places I have capitalized, but this is a mistake. You don't have to. Okay, you don't have to, until and unless this is the first letter in your sentence, in your answer, then you can, but otherwise no. Okay, otherwise you will name them with small letters. Okay, so gallium oxide. Okay, ide is telling me that there are only two elements in this. And so what is the symbol for gallium? Where is gallium? I did not make gallium here, so let me fetch. Okay, where is gallium? Okay, even I don't know. Okay, gallium is here. Gallium is here. That means it's here. Gallium is here. So it lives in the third group, and so the charge would be +3. And this is oxygen. Oxygen lives in the sixth group, and so it has charge of -2. Now, are they balanced? No. How can I balance this? Who will tell me? Okay, people who are not interested in answering this question, please lower your hands. And only those who want to answer, keep their hands up. Fatima Mohsen. Yes, Fatima Mohsen?
Hello?
Yes, hello. Fatima Mohsen, can you tell me how to balance this?
Yeah, teacher, we will cross it. I will write again GA. GA again.
Okay, GA again. Okay. Okay.
Yeah, the answer is +3
Okay.
and -2. Oh, sorry. -2, yeah.
What, yeah?
-2 +3.
Okay, okay. So what should I add, and what should I didn't understand. So this would be +6. Is that what you're saying?
Yeah.
Okay. And so now is it balanced with only 1, -2, and +6?
No.
So then what should we do?
We'll write -2 here.
Okay.
-1.
One more?
No.
Okay.
The answer will be 1.
So now if we have two oxides, -2, -2, this will give me -4. It's still not balanced. Yes, Sidra is saying add another. Okay. So I'm adding one more. Okay. Now I have -6. Now they're balanced. Yeah.
Okay. Yeah.
Because they are not balanced. +3 -2. Yeah. Okay. So now how many galliums do I have? Fatma, tell me the final answer. What should I write?
Ga.
Yes.
Ga.
So how many are there?
6. Okay.
No. The number of ions. The number of ions. Don't tell me the total charge. No. The number of ions.
2.
2. Very good. 2. Okay. Then?
And O3.
Very good job. Yes. O3. Okay. So this means that I have 3 of -2 oxygen and then 2 of +3. So total would give me +6 -6, and say they will cancel out, and so I have neutral. Ga2O3. Did you understand this, Fatma?
Yes.
Okay, good. Try. Okay, I will do lots and lots of questions like this until you get good at it. Okay, try to write the formulae of all the compounds. Where you get stuck, you ask me, or you ask somebody. Okay. Okay, good job. Now go ahead and mute yourself. Okay. Now let's do this aluminum nitride. Okay, and this time I'll do it myself. I have this bad habit of writing capital letters. So aluminum nitride. Okay, so it is telling me that there are 2 elements, aluminum and nitrogen. Okay, what's aluminum lives here, +3 charge. Nitrogen lives in the 5th group, -3 charge. So yeah, they are balancing. No need to add anything. So they are balancing. Okay, no need to add or subtract anything. So that's simple. Aluminum nitride. Did you understand this? This is easy. Okay. So what are we doing actually? If you look at all of this, is there a shortcut? Do we have to write like this all the time to write the formulae? When we are in a hurry or when we are trying to balancing equations, do we have to do all of this, do all this working? No, there's a shortcut. Okay. The shortcut is that you write the charge of the element on the right side next to the symbol of the element on the left side, and you write the charge of the metal on the left side on the right side of the symbol of the element that you're writing on the right side. So what I'm trying to say is that this is what I'm trying to say. Calcium iodide, right? This has -1, this has +2. Okay, +2 would go here, -1 would go here. Okay, so calcium iodide. Did you understand? You crisscross the charges. You write the charge of this next to the first element, and you write the charge of the first element next to the second element. You crisscross. Is that easy? Let me tell you. For example, aluminum oxide. Charge on aluminum is +3, right? Aluminum is +3. +3. Charge on oxygen is -2. So -2. I will crisscross right here, right here. So Al, I will write 2 next to aluminum and 3 next to oxygen. Did you understand this? I hope you understood this. So I am basically doing the same thing, but this is a shortcut. You just crisscross their charges. Okay? Okay, did you understand, Sidra? Okay. So let's go ahead and talk about now the ionic compounds which have transition metals. Ionic compounds that have transition metals. Now, transition metals, what's special about transition metals? The thing about transition metals is that they have more than one charge. These transition metals, they have more than one charge. That's the problem. They have more than one charge. Meaning to say that, you know, in the rest of these elements, you saw that this whole group had +1, this whole group had +2, and they don't have any other charge. I mean, these elements will always have +2 charge. These elements in their ionic form will only have +3 charge. Their ions will only have -3, and so on and so forth. But these have more than one. So we get confused. Like, you know, which ion are you talking about? Except for silver and zinc. Okay, silver and zinc are the only two exceptions in transition metals which have only one charge. Okay, silver has +1 charge and zinc has +2 charge always. So though they are transition, but they have only one charge. The rest of the transition metals have more than one. Like iron can be sometimes 2+, at other times it can be 3+. Okay, iron is here. Where did iron go? Oh, I didn't write iron. Can you show me where the iron is? It's next to cobalt, right? Next to nickel, cobalt, and then this is iron. Okay, okay. And then, you know, chromium can be 2+ and chromium can be 3+. So chromium has two charges. Can even have more, you know, chromium can have 6. Some transition elements have 4 to 5 different types of ions in which they have different charges. What does this mean? This means that sometimes chromium loses 2 electrons. In some reactions, chromium loses 3 electrons. In other reactions, chromium loses 6 electrons. Now you might get puzzled and ask, you know, how is that? So that is why I'm saying that we will leave the transition metals for now. We will not discuss them. And you don't have to go into the details of transition metals. This will be done in A levels, advanced levels. It is in advanced levels that you study transition metals in detail. But in IGCSE, just understand a few properties of these transition metals. This is one of them, that they have variable charges. They have more than one charge, okay? Don't do unnecessarily, okay? Okay, now, so when we have, like for example, if you have 2 Mariams in your class, or you have 2 Ahmads in your class, now these are pretty common names. So what do? Whenever you say Mariam, oh, Mariam did this. So your next question would be, which Mariam? Mariam Ayaz or Mariam Noman, you know, like you will take your complete name. You will take complete name to differentiate between the two. In the same way, when we say iron oxide, the question arises, which iron? Which iron? 2+ or 3+? So that is why it is important while naming these ionic compounds which have transition metals to mention. You have to mention which iron are you talking about. For example, iron 2 oxide. Iron 2 oxide. Now, what does this parentheses, what do these Roman numerals parentheses in bracket mean? This is indicating that we are talking about iron 2+. Okay, this is indicating that we are talking about iron 2+. Like just like you will say Mariam Ijaz, I'm talking about Mariam Ijaz. Okay, you will take the complete name because there is no other Mariam Ijaz. The other Mariam is some other Mariam. Okay, she must be Mariam Ayaz maybe, or Mariam Numan or whatever. So in the same way, now if this was iron 3 oxide, then we will write like this, iron 3 oxide. So that's why we have to use these brackets. That's why we use brackets to differentiate which iron are we talking about, iron 2 or iron 3. Do you understand this? Okay, now let's try to write the formula of this. Okay, so again, symbol of this iron is Fe. Symbol is Fe. Okay, and because it's a transition metal, it's easy in case of transition metals. If you have the Roman numeral already given in the bracket, so you know it's 2. It's 2 plus. The charge is 2 plus, so that's easy. Oxide, that means oxygen, right? Oxygen is in 7th group -2. So the charge would be -2. So are they balanced? Is this balanced? 2 plus and -2? Yes, balanced. We don't need to add anything. Ammar, please. So no need to add anything. FeO is the compound, is the formula. Okay, okay. Okay, remove him. Okay, copper 2 chloride. Copper 2 chloride. Who will do this? Who will do copper 2 chloride? Okay, Muhammad Abdul Rahman. I'm unmuting you. Yes, Muhammad Abdul Rahman. Now, can you do copper 2 chloride with this explanation in mind? Can you do copper 2 chloride? And it's okay to be wrong. Don't worry.
Okay, teacher.
Okay.
First, we will write
Yes.
copper 2, C2.
Yeah, Cu is the symbol. Okay. So what's the charge on copper 2 plus?
2 plus.
Yes, it's 2 plus. Yes, and then this is chloride.
CO.
CO, chlorine, Cl.
Cl.
Okay, this is chlorine. CO is another transition element. It's called cobalt. Okay, CO is another transition metal. It's called cobalt. Okay, okay. So tell me.
Cl.
Cl. What's the charge?
-1.
-1. So is this balanced?
No.
No. Can we crisscross the charges?
No.
Yes, we can. Write this here and write this here.
Teacher, when we cannot?
When we cannot? Are you asking?
Yes.
No, you can. All the time you can. But in covalent compounds, it's different. Okay, this is ionic. We are doing ionic. In covalent, it's different. Okay, we will do covalent compounds separately. Okay.
Okay.
Okay. So now if I crisscross, what will I? So give me the final.
Cu.
Very good.
Cl.
Very good. Not +2, only 2. Okay. Not +2, only 2. Okay.
Okay.
Okay. So 2. Okay. So now this is the final. Or you can do it another way, that if this is +2 and this is Cl minus. Okay. Then we will add one more chloride to balance it, because we have +2, so we want -2. Balance it to get CuCl2. Okay. Okay. Now tin 4 sulfide. Okay, now let me take your questions. Okay, Hamid Azam, very good question. What if two metals bond together? Two metals can never bond together. Okay, you will not find, very rarely, you will not find two metals bonding together. Why? Because both of them are trying to get rid of the electrons. They want somebody who can accept. Okay, they don't want to share, they want to give away. And both the metals are trying to give away, so they can never bond together. Hamid Azam. Okay, how do we know if a transition metal has a negative charge? Metals never have negative charge because they never accept electrons. Remember, they are metals. Okay, metals always give away electrons. They never accept because they have only one or two or less number of electrons. So it's easier for them to lose. They will never want to gain. That's what makes them metal, that they lose electrons. Okay, I am what is this Abdullah Khan 6C? Abdullah Khan, who is this? Okay, can we balance in an easier way? Yes, Hania Amjad, I just told you to crisscross. Okay, can metalloids combine? I will not answer this question because you're not using your real name, so I will not answer your question. Can metalloids combine? I will not answer this question. Abdullah Khan 6C, we have noted down your ID, and you will not be allowed again in the class. Okay, how many kinds of elements are in the periodic table? You can go ahead and count them. I don't remember the exact number. Okay, okay, Miss, I'm very sorry to interrupt, but the way you are balancing is very difficult with the ions, and I'm from grade 7. I want to refresh my memory, and there is a better and easier way to balance without ions. There are a lot of videos on YouTube for that. Thank you. So please go ahead, leave the meeting. Leave the meeting and watch the videos, please. Okay, go ahead. I did not force you. Okay. Yeah. Okay. How do we know if a transition metal has a negative charge? How do we know if a transition metal has a negative charge? Metals can never have negative charge. Okay, metals can never have negative charge. Okay, when we write Roman number in the brackets, how do we know if it is positive or negative? That's a very good question. Now, Roman numerals, I told you, are only for transition metals. Roman numerals are only for transition metals. So the metals always lose. So it's always positive. You understand this? Transition metals are the ones which have variable charges, and they're always positive because they are metals and they will lose electrons. Okay. 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 How do I? Okay. Miss, can you also send these pages in group like you sent? Yes, sure, Sariha. Yes, I will. Okay. Okay. What are the charges of carbon and silicon? Okay, so you did not attend my last classes. Carbon and silicon, they are in the 4th group. So yeah, they share. So it can be +4 or -4 depending upon what is easier for them. So, you know, because the number of electrons that they require to complete their octet and that they need to lose to complete their octet is the same, because they have 4 electrons in their outermost shell. Because remember, this is a 4th group. So 4th group have 4 electrons in their outermost shell. So they can either gain 4 more electrons or they will lose 4 electrons, okay, to be stable. So what they do, I mean, losing 4 electrons is very energy requiring. So what they do is that they simply share. Okay, so we don't write the charges on them. They don't form charges usually. Okay. Okay. That was a good question. Today you guys are asking good questions. Alhamdulillah. How many charges does hydrogen have? Hydrogen has only 1. By the way, hydrogen is, it's a good thing that you reminded me. Hydrogen has only 1 electron, if you remember. Its atomic number is 1. And so it has only 1 electron, and it can lose that 1 electron, or it can share another electron and can have 2 in its outermost, I mean, its single shell. Or it can, you know, just give away and you know, what will be left behind will be just a proton. If you remember the atomic structure of hydrogen, Urwa, okay? Abdullah Musawwir, will we also have to write minus and addition sign in the easy way? Now, you know, the reason why I explained you this is so that you understand, so that you understand the basics behind how to write the formulae, okay? And so, you know, crisscrossing is just a shortcut way, easy way, okay? Okay. Yes. Okay, I don't want anybody in the chat window telling me that it is easy or it is hard. Okay, I am doing this for everybody. Okay, so maybe it is easy for you, but I have to, you know, take care of all the students. Okay, whoever finds that, you know, it's easy for them, they don't need it, they can leave the meeting. Yes, the shortcut works all the time. Okay, Ifra Mutakabbir. Okay, okay. Miss tin is not a transition metal, so why did you write it with Roman numeral? Tin, where is tin? Yeah, it's not a transition metal. That's a very good question. But again, it is in that fourth group, which can have either +4 or -4. So that is why sometimes it is mentioned. Okay, Iman Javed, that's a very good question. Okay, like not over lithium or fluorine. Yeah, because lithium and fluorine is non-metal, lithium is a metal. So they always have the same charge. So no need to write in numerals. Okay, another thing that I want to mention is that when you, for example, if you're trying to write lithium oxide, oxide has 2-, lithium has +1. Now, you know, lithium will always have +1. Lithium will always have +1. So if you write lithium 1 oxide, that will be wrong. Okay, this Roman numeral is written only next to transition metals, or sometimes if you have any compound involving this fourth group, otherwise you won't. Okay, okay, will we also have to write, okay, how many charges does hydrogen have? Okay, when we write Roman number in the brackets, how do we know if it is positive or negative? I've answered this question. Okay. Abdullah Khan 6C. Okay, remember this. Abdullah Khan 6C morning. Why doesn't group 4 have charge? Javeri, I've answered that question. Why doesn't group 4 have charge? That's because they don't give away and accept, but they share. So they don't form a charge. Yes, Hiba Nasir, kindly try to log in with your real name next time, okay? Can metalloids combine? Yes, they can. Yes, they can. Metalloids are combination of metals and non-metals, okay? What is the charge for group 4? I just told you it depends, okay, on the compound that they're making. It can be +4, it can be -4, but usually it's +4. Okay, will we do the transition metals in these classes? Teacher, the staircase on the right side is the metals. The staircase, you know, is a division line between the metals and non-metals, and the elements around the staircase are called metalloids. Okay. If we swap the numbers in CuCl, why won't we add 1 as well? No, we don't write 1. We don't mention 1. When we don't write anything, it is understood that it's 1. Can you do a question on them? Question on what, Zoris? Hamid Azam. Can you do a question on them? What's them? Can you tell difference between physics and chemistry? They both relate to atoms, so what is the difference? That's a good question. All the 3 sciences overlap. Physics, chemistry, biology. All the 3 sciences overlap. So yes, I agree with you. In many countries, they are taught together. Okay, can't hydrogen make +1 or -1 charge? It usually makes +1 charge, Aisha. It does not make a -1. It does not form an anion because it has only 1 proton. So it's easier for it to lose than to gain 1 more. I mean, 1 proton does not have enough attraction for 2 electrons, okay? How many charges does nitrogen have? Nitrogen is -3, I mean, when it forms compounds. Okay, Aisha Sarfaraz, very good question. Why isn't hydrogen in a proper group? That's a very good question, yes. Because hydrogen has only 1 electron, so sometimes it loses that 1 electron, and in that case, it should be grouped in the first group. It should be arranged in the first group. But remember, the first group are all metals. hydrogen is not a metal. It is a non-metal. Why? When we will do the properties of metals, you will realize that all the metals are solid and they are shiny, whereas hydrogen is a gas. So that shows that this is not a metal, but it does form +1 ion. So therefore, it is in between. So that is why some scientists group it in, the first group, and others just keep it here. Okay, simple. Can you do tin sulfide? Okay, let's do tin sulfide. Miss, why is in hydrogen? Okay, this I've already. How do we know that how much atomic number an element has and in which area? Mas Babi, I think you have not attended my last lectures. Please attend my listen to my recordings and then ask. Okay, Miss Tin is not a transition. Okay. Okay, this is done. Formula of tin sulfide, and then I am ending the meeting. Okay, I'm just doing this tin sulfide because everybody is asking, and then no, group 4 should not be in transition metals because they are not metals, Wajiha. When we will do the periodic table, you will understand this better. Okay, are you going to explain anything more now, or no? I'm not going to answer this question. Are you going to explain? Okay. Tin, a symbol is Sn. Sulfide is sulfur. Ide means only 2 elements. Sulfur is -2. Okay, so -2 charge. Tin, where is tin? Yeah, it is here. So we will take +4. Now what to take? It has 2 charges, right? Now what to take? +4 or -4? Now you cannot have 2 minuses together. You cannot have 2 minuses together, meaning, what does this negative mean? This means that this has pulled the electron more towards itself. Okay, so I mean both the atoms cannot be pulling the electrons, towards themselves. So this is -2 and this is +4, right? Okay, so now is this balanced? No, we have +4 and we have -2. So yeah, we can add one more, -2, and so now we have 1 tin and 1 sulfur. Okay, simple. Now if you do it the crisscross method, +4 -2, 2 would come here, 4 would come here. Okay, and remember, we always, not always, I mean when you are writing a formula, remember most of them are in their simplest forms, right? So we will cancel. Okay, no, I'm sorry. This is, yeah, okay. So this won't work this way. Okay, this won't work this way. Why is this? Yeah, because this is a metalloid. So yeah, this is a little complicated. But yeah, so that is why this method you can never go wrong. This is a shortcut. Sometimes it works, sometimes it doesn't work. So this won't work. Okay, so this method is the one that will give you the correct answer. Okay, so it's, oh, I'm so sorry. Yeah, it is 2. Yeah. Oh, sorry. Yeah, sorry. This is the, yeah, so okay. I thought, yeah, I got confused a little. Okay, so this is the final answer. Okay, tin sulfide. Okay, assalamu alaikum wa rahmatullahi wa barakatuh.